Hello everyone, welcome to the lecture series of 8085 microprocessor. This is lecture number 20. Today we'll be learning about stack and subroutines. So first of all we'll study stack. So what is stack? We have in the very beginning lectures we saw there is something called as stack pointer. So stack pointer is of course related to stack. So what is a stack? So stack is a set of memory locations in the read-write memory, and it is defined by the programmer in the main program. And these memory locations are used to store the data temporarily during the execution of the program. So what happens in case of 8085? As we know, there are limited number of registers. The registers which are available to us are A, then B, C, D, E, H, L. So these are the 7 registers which are available to the user. Now it may happen that we may sometimes we are doing a big program, okay, and we need some more registers. Apart from this, we need to store some data, but now these registers have been already used and we are running short of registers, and if we store some data in these registers, then the original data which is in the register will be destroyed. So we need to retain that data and want to store the new data. So what it can be done is we can store the contents of these registers onto some memory location, and that memory location is called as a stack. So what we do is we temporarily store the data of any of these registers, and then those data are stored on the stack. We can use those registers, and when our job is done, then we can bring back the contents from that memory location onto the registers again and continue with our task. So this is the use of the stack. There are some instructions related to stack. Now these are the 3 instructions which are related to stack. The very first instruction is LXI SP 16-bit address. Now LXI, we have already seen 3 instructions: LXI B, LXI D, LXI H. Now this is LXI SP. So LXI SP is of course a 3-byte instruction. This instruction is used to initialize the stack pointer. So suppose if we write like LXI SP 2030, so our stack, then the location stack starts from 2030. If we initialize LXI SP as 2030, so our stack location in the read-write memory starts from 2030. But it is a good practice that we initialize the stack at the highest available memory location. So what do we mean by that? Now in case of 8085, we have these memory locations. They are starting from 0000 to FFFF. So FFFF is the highest available memory location. So in case if this location is available to us, okay, and our program may be starting from suppose 8000. So suppose the read-write memory location is available from 8000 to FFFF, then we initialize the stack pointer to the highest available memory location. The reason is that our program, it grows linearly from 8000 to ahead 8001, 2, 3, 4 and so on, but the stack, it grows in the reverse order. Okay, the stack grows in the reverse order while the program goes in the forward way. So if we don't initialize it to the highest available memory location, initialize somewhere here, then it may also corrupt our program. It may clash with our program set. So it is a good practice that we initialize the stack to the highest available memory location. If it is FFFF, then it was initialized with FFFF. Now next instruction is with respect to stack is push RP. So push RP, there are 4 instructions with respect to push RP. This is a 1-byte instruction. We have push B, then push D, then push H, and push PSW. So this push B instruction, it stores the contents of register B and C onto the stack. How this operation is occurring, we'll see in the next slide. And with respect to push D, okay, all these push instructions are of 1 byte, and this push D instruction, it stores the contents of DE onto the stack. And similarly push H, it stores the contents of HL register. This is DE and this is HL onto the stack. And push PSW, it stores the contents of register A plus the flag register. So PSW means program status word, and it is a combination of register A and the flag register. Both are of course 8 bits. So this data is stored onto the stack. Then we also have, apart from push, we also have pop. So it is natural that as there are 3 push, so we also have 3 pop instructions. So we have pop B, then we have pop D, then pop H, and pop PSW. Now this instruction pop B, it stores the contents from the stack onto register B and C. Okay? And this pop D instruction, it stores the contents from the stack onto register D and E, register pair D and E, and pop H, it stores the contents from the stack onto this HL register pair, and pop PSW, it stores the contents from the stack onto register A and flag register. Now we'll see one example and see the working of the stack. Now we'll understand the working of stack using some instructions. So here I have written some instructions, like the first instruction is LXI SP FF, then LXI B, LXI D, LXI H, and some push and pop instructions. So we start with the first instruction, LXI SP FF. Now of course this is a 3-byte instruction. I am not running the hex code because I just want to demonstrate the working of the stack. So with this LXI SP, the stack pointer is initialized at this point. So this is our stack pointer. So this is the stack pointer which is initialized at FF. Now next instruction is LXI B 1020. So we know this, because of this instruction, register B will contain 10 and C will contain 20. And with this LXI D, we know this register D, it will contain 30, and register E, it will contain 40. And this LXI H 5060, register H will contain 50 stored, and this is 60 is stored in L. So this is all we have done previously also. Now let us see what happens with push B. Now when this push B is executed, okay, when this particular instruction push B is executed, what happens is that the stack pointer, okay, it decrements by 1. Okay, so here we have the stack pointer, so it decrements by 1. Okay, and the content of register B are stored in that location. So the content of B, as we know, the content of B is 10, so 10 gets stored here. So it is not stored at that point, but 1 less than that. Okay, then stack pointer is decremented again. Okay, it will decrement it again, and the content of register C are stored at that particular location. So this C register, the contents is 20, so this 20, it gets stored here. Okay. So the stack pointer is this point. Now stack pointer, the new location is this one. So this is where we have the stack pointer. Okay, I'll just move this stack pointer here. So this is now, okay, this is the new location of the stack pointer. Okay, this is the stack pointer now. Now next what we have is push D. Now when push D is executed, now this is the next instruction, push D. Okay, this is what we have, the push D instruction. Now this push D, when this is executed, the stack pointer decrements and the contents of D are stored. So D contains 30, so this 30 will be stored here, and it decrements again, and the content of E are stored. So the stack location is now, the stack pointer is at this point. So this is the new stack location, this is the stack pointer. Now next, when push H is executed, so stack pointer decrements, so it decrements, and the contents of H, that is 50, is stored here. It decrements again, and the content of L are stored here. So this is 60. So this becomes the new stack location. The stack pointer is at this point now. So here this is the stack pointer at this point, and we can just grab this. Now we must carefully observe that what happens with push. So after every push instruction, as we started from this, the stack pointer first decrements, then stores, again decrements, and then stores. So one push instruction, it leads to 2 decrement and 2 stores. But the first operation is decrement. It decrements the stack pointer, okay, and the data from that higher order register. If it is BC, so B is the higher order, so higher order is stored first, and then it decrements again, and the low order is stored then. Okay, so this is how the stack is stored. So the last data which is stored is from HL. So when we want to retrieve the data, from the stack onto the register, so this stack, it follows the last in first out operation. So the last which was pushed was H, so we must carefully see that we must pop H first. If we pop B instead of, suppose after push H, if we write pop B, then the content of which are on the top of the stack, now top is this one, 5060 5060, so they will be stored in B. So the last pushed was H, so the first very pop, the which will be pop should be HL, then D, and then B. So now what happens with pop H? When instruction pop H is executed, the content of the stack pointer, this is stack pointer at this point, okay, so the content of this location is 60, so 60 it gets stored in register L. Okay, so I can just make a marking this. So suppose this gets stored in L, and the stack pointer is incremented, and the next content is stored in H, and the stack pointer is incremented again. So the new stack location, okay, the stack pointer was previously at this point. Now because of the push pop instruction, the stack pointer comes at this point. Okay, then we again give the instruction pop D. So this is pop D. So with pop D, what happens? Okay, this is pop D. With pop D, the content of that particular stack pointer, that is 40, they are stored in E register, and the next data, the stack pointer increments, and the contents 30 are stored in D. So this goes on. See, the difference with pop is that when pop instruction is executed, the data at the stack pointer is stored and the stack pointer is incremented. The data of that next pointer is again stored into the higher order register, and the stack pointer is incremented again. So what the basic thing here is, with respect to push instruction, so it is decrement, store, decrement, store. With pop, we have store, then increment, then again store, then increment. So this continues at the final pop B. What will happen is that with the final pop B, the data at this particular, the stack pointer will be of course at this point, stack pointer of this instruction will be at this point. So after pop B, this content will be stored in register C, okay, and the stack pointer will be incremented, and this content will be stored in B, and the stack pointer will come to this point. So this is how the stack works. Okay, so that's all for this particular session on stacks. In the next lecture we will study subroutines. Okay, thanks for watching.